Hello everyone! Welcome back for another video with us. In this time, we are going to present the experiment number 1, which is entitled Determination of Specific Gravity, Water Absorption, and Density of Aggregates and Filters. I am Rey Aceret, and together with my group mates Michael Adame, Danika Ajoc, and Charles Asio, we will bring the best lesson experience that we can offer to you in the field of civil engineering. So, let's get started! The experiment video's inside scoop is to present the detailed computation of determining the specific gravity, water absorption, and densities of sample aggregates. ASTM C128, or the standard test method for relative density, or we call specific gravity and absorption of fine aggregates, and ASTM D4254, or the standard test methods for minimum index density and unit weight of soils and calculation of relative density, were the ASTM standards followed. The specific gravity and porosity of aggregates greatly influence the strength and water absorption capacity in concrete. A low specific gravity may indicate high porosity, which often results in poor durability and the low strength of aggregates. In addition, the relative density is used to identify the arrangement of individual grains of coarse soils to one another. With this knowledge, it is able to make snap adjustments about the soil stability or displacement capacity and its water permeability within the excavation. For this experiment, we target to meet these three objectives. First is to determine the relative density of aggregates. Second, to determine the water absorption for aggregate use for concrete mixes or construction. And lastly, to determine the different types of gravities, apparent, bulk, and bulk SSD of the coarse aggregate. The scope of this experiment is the procedure covers the method of determining the relative density, specific gravity, and water absorption of aggregates in accordance with the specific designated ASTM standards. ASTM C128 is used for the standard test method for relative density and absorption of fine aggregates, and ASTM D4254 is the standard test used for minimum index density and unit weight of soils and calculation of relative density.
The materials used in Part 1, Relative Density and Water Absorption of Aggregates, is first, a drying oven with temperature of 105 degrees Celsius. Second, a balance readable to 0.5 grams. Third, a vessel up to 2 kilograms capacity. Fourth, 2 dry soft absorbent cloths. Fifth, a shallow tray. Sixth, tin can containers to take the sample. Seventh, number 10 sieve. And eighth, number 200 sieve. The materials used in Part 2, Specific Gravity Determination of Coarse Aggregates, is first, balance. Second, container. Third, water tank. Fourth, drying towel. And fifth, oven. In test number 1, relative density and water absorption of aggregates, its initial procedures are: first, fully immerse the samples, both coarse and fine aggregates, separately. Second, weigh the tin can containers to be used in the following procedures. Next is test proper fine aggregates. First, take a portion of the sample from the vessel passing through a number 10 sieve. Thoroughly wash it on the number 200 test sieve to remove finer particles. Remember, remove the entrapped air with gentle agitation. Second, weigh the sample, container plus water plus sample, to get the mass of the water plus sample. Third, the sample was removed from the container and drained for a couple of minutes. Use dry cloth or used newspaper and spread the aggregates. The sample was left exposed to air away from direct sunlight until visible films of water were removed. Make sure that the aggregates should still have a damp appearance. Fourth, while the aggregates were drying from air, the tin can container was filled with water. It should be from the level of the marking from the previous water, and weigh the container plus water and get the mass of the water alone. Fifth, the water was removed from the container and the samples from step 3 were returned, aggregates that are dried in the cloth or newspaper, to the container. The container plus sample was weighed to get the mass of the sample alone. Sixth, the sample aggregates were removed from the container and gently transferred to a separate container that is suitable for a laboratory oven. The aggregates were oven dried at 105 degrees Celsius for 24 hours. Seventh, after drying, weigh to obtain the mass of the dry sample of the aggregates.
Now, let's proceed to test proper 2 for the coarse aggregates. The procedures for the fine aggregates were repeated. However, for the step 1, the sample aggregates must be passing through number 4 sieve and must be retained from the number 10 sieve. The sample was washed using a number 10 sieve. Test number 2. Specific gravity determination of aggregates. Coarse aggregates. Number 1. Samples of the aggregates were obtained from the laboratory. If the samples obtained are in their naturally moist condition, the requirements for initial drying is eliminated. The method of drying, in which is to dry the samples to a constant weight at a temperature of 110 plus or minus 5 degrees Celsius. After drying, cool at room temperature for 1 to 3 hours. If the surface of the particles in the sample have been kept continuously wet until the test, the 24-hour soaking may also be eliminated. Method for 24-hour soaking: immerse the aggregate in water at room temperature for a period of 24 plus minus 4 hours. Number 2. The test samples from the water were removed and rolled in a large absorbent cloth until visible films of water were removed. The larger particles of the aggregates were wiped and dried individually by using cloth. Moving streams of air may be used to assist in drying. Test samples were weighed in the saturated surface dry condition. The results were recorded to the subsequent weights to the nearest 0.5 grams or 0.5% of the sample weight. After weighing the samples, the weight of the container was added to the weight of the water. After weighing, the saturated surface dry test sample was immediately placed in the sample container. Number 6. Dry the test sample to a constant weight in the laboratory oven at the temperature of 110 plus or minus 5 degrees Celsius for a period of 24 hours. After drying the samples in the laboratory oven, cool the sample in air temperature for 1 to 3 hours or until the aggregate has cooled to a temperature that is safe to handle, and weigh the oven-dried samples. Lastly, gather all the data and solve for the bulk-specific gravity SSD, apparent specific gravity, and percentage of water absorption.
The first part is the results for relative densities and water absorption of the sand or fine aggregate. First trial arrived at a value of negative 12.158 for dry relative density, negative 9.895 for saturated relative density, 9.625 for apparent relative density, and negative 18.615% of water absorption. The second trial on the other side has negative 2.327 for dry relative density, negative 5.212 for saturated relative density, 0.599 apparent relative density, and 123.967% of water absorption. The average values for the following are negative 7.2425, negative 7.5535, 4.5113, and 52.676% with the same order. In addition, coarse aggregate is also tested for these different types of densities. Relative density has first and second trial values of 16.294 and negative 6.767, having an average value of 4.764. Computed saturated relative density is 16.088 and negative 6.877 for the first and second trials with an average value of 4.606. Apparent relative density has a calculated average of 3.707, which is 13.512 on the first trial and negative 6.099 in the second. The average water absorption in the coarse aggregate is 0.178%. Lastly, the specific gravities and the water absorption of coarse aggregates. Bulk density recorded 127.5 in the first trial and negative 5.384 in the second to arrive at its average value of 61.058. SSD bulk specific gravity has an average value of 46.92 from its trial values, which are 98.5 and negative 4.657. 4.25 and negative 19.741 are the values of apparent specific gravity, which is an average of negative 7.746. The desirable positive water absorption does not mean for the average value calculated, that is negative 11.44%. In this part, you can see our solutions on how we attain those numerical values starting from the relative density and water absorption of fine and coarse aggregates and the relative density and water absorption of coarse aggregates.